Topic 1.2, Prerequisite Notes. We begin with explaining what a function is. Functions are special types of relations. A function in math is written as a rule, and that rule gives a unique output for every input. We've already referred to those as domain and range. We can use a graph to represent a function. We can use a mapping diagram, that's down there, to represent a function. We can use a list of ordered pairs to represent a function. Functions are generally named using the letter F. So you will see f of x used a lot. But you can also name a function using g of x, h of x, etc. As we said before in Topic 1.1, the domain of the function is defined as the set of all values that the function can use as an input. And the range is the values that come out once you use that input. So in our first graph, we see a picture of a curve, the green curve. For this to be a function, we must see that every input has exactly one output. So I'm looking here on my graph, and I see at -3 as an input, there is an output of 5. And then if I look down here, I see at 0, there's an input of -5. And as I trace the path of the curve, I see that for every input, there is exactly one output. And so we would consider this a function. Once we know that, we can go ahead and describe the domain and range. And we did that in Topic 1.1 using interval notation. So the domain here would be from -4 to 3. And we recall brackets to include -4, parentheses to not include 3. That range, lowest y, -5, highest y, +5. Now you might think don't include it because there's an open circle, but there's also a closed circle. So there's an open circle at 3,5, but there's a closed circle at -3,5. So 5 is actually a value in the domain. If we look at this second graph, this is also a function. For every input, there is exactly one output. This is a type of function that represents, what does it say? The size of the average U.S. houses in feet squared, or squared footage, over a period of time from 1920 to 2010. If I were to describe the domain of this function, it would be described as 1920 to 2010. Those are the actual years. If you wanted to consider 1920 year 0, you could also describe it as 0 to how many years is that? That's 90 years. But you would have to indicate that. The range is the square footage of the house. So the square footage of the house ranges from 1,000 square feet up to 2,400 square feet. For this particular graph, notice that there are designated dots along the graph. And those can also be written as ordered pairs, which would indicate a set of inputs along with a set of outputs. We can also represent functions using something called a mapping diagram. And a mapping diagram does exactly what the word map says. It connects an input to an output. So remember, inputs, outputs. this particular mapping, the domain would be listed as -35, -5, 0. The range would be listed as 1, 4, 22. This particular mapping is not a function. Okay, the reason that it's not a function is right here. This -35 maps to 1, and it maps to 22. In order for it to be a function, every input can only map to exactly one output. So this particular mapping diagram is not a function. It would be called a relation. Now we're going to move on to evaluating functions. You did a little bit of this in the Delta math. How to evaluate a function, and what does this mean graphically? To evaluate a function means to substitute the indicated value into the equation of the function. In other words, plug it in. So if you had f of x equals 2x plus 1, and I asked you to evaluate f of -3, you would be taking that -3 and substituting it in wherever you see x. If you see 1x, you only substitute it in 1. If you see x show up in several terms, you substitute it into all the terms. So that would be 2 substituted in -3 plus 1. That's -6 plus 1, which is -5. Now, this notation, f of -3 equals -5, will translate into the following. On the graph of this function, there will be the point -3, -5 in the coordinate plane. So -3 was my input, -5 was my output, and that creates the point -3, -5 on the graph. If you want to graph a function, you can keep evaluating for several values of x until you have enough to create a picture or a graph of that function. So let's go through some different examples, and let's review some algebraic expressions within the functions and what to do in terms of operations. So we'll start with f of -2. Given our function f of x equals 2, here's a little reminder, that's absolute value x minus 1 plus 5. So what we're going to do is we're going to replace -2 in the function. So that's going to be 2 absolute value, -2 minus 1 absolute value plus 5. 2 absolute value, -3 plus 5. We know that the absolute value of -3 is +3. 6 plus 5 is 11. What does this mean graphically? -2 is in the domain. We consider that the input of the function, and 11 is in the range. So -2 is the input. So let's just remember that, input, and 11 is the output. And that translates into -2, 11 will be a point on the function or graph of the function. That's the absolute value function. Given f of x equals -4x cubed, let's zoom into that. That's supposed to be a negative in front of that there. So -4x cubed minus 2x, what is f of -1? So f of -1 means wherever I see x, So here and here, I'm going to replace it with -1. Something to keep in mind. When you replace a variable with a number, if that variable has an exponent on it, you must enclose the number in parentheses before you raise it to the indicated exponent. So -4 parentheses, -1 cubed. Please notice my use of parentheses. -2 times -1. And now you simplify. I suggest you use a calculator. If you don't have a calculator, you'll have to do it mental math. -1 cubed means -1 times -1 times -1. It's -1. -4 times -1 is 4, minus 2 times -1 is a -2. You're going to get 6. So f of -1 equals 6. Translates into the point -1, 6 on the graph. So keep that in mind because we're going to begin graphing functions. And we're going to begin graphing them by evaluating the function first. Okay, number 3, f of -4. That's going to be 1 over -4 plus 3, and then -2. Oh, back it up a sec. Number 2, that was called the cubic function because that x is being raised to the 3rd power, so cubic. Number 3 is called a rational function. Rational coming from the word ratio, coming from the fact that there's a fraction in that function. So let's simplify it. -4 plus 3 is -1, so that's 1 over -1 minus 2. So that's -1 minus 2, which equals -3. So f of -4 equals -3. Square root function, that's the next one we're going to evaluate. So that means we're going to do f of 16. And we call this the square root function because hopefully you see that there is a variable under the square root symbol. So 2 times the square root of 16 plus 3. Do your math. 2 times the square root of 16 means 2 times 4 plus 3. 8 plus 3 is 11. So f of 16 equals 11. And keep in mind, that means that 16 comma 11 is on the graph. And so if you wanted to build a graph of this function, you could continue to place inputs in, get some outputs, collect some ordered pairs, and then draw what it looks like. Number 5, this is the cube root function. You see there's a little 3 tucked into that square root symbol. That means it's not a square root anymore. It's a cube root. All right, so let's evaluate f of 10. So that's going to be the cube root of 10 subtract 2 plus 1. Cube root of 8 plus 1. Where will you find cube root on your calculator? It's on the graphing calculator. And it's under the math menu. Not sure exactly which. I think it might be math 4. Or cube root means what number times itself 3 times is 8. So the cube root of 8 means what number times itself 3 times gives me 8? And that's 2. So the cube root of 8 is 2 plus 1 is 3. So f of 10 equals 3. But I encourage you to search for it on the graphing calculator because it will go faster. All right, so now that we learned how to evaluate functions, let's use that to actually create a graph of the function. So you see here a picture of a t-chart. This is called a t-chart and a graph. And our first function that we're going to graph is g of x equals -5. Notice I'm not naming it with f of x We can name a function whatever we want to. There is nothing listed in the x side of the t-chart, which means you can choose what to place there. I will generally choose a couple of negative numbers, 0, and a couple of positive numbers, and I'll kind of keep them together. So how about we choose -3, -2, -1, 0, 1, 2, 3. So we're going to begin by plugging in -3. So if I come to the function g of -3, I notice that this particular function doesn't have an x variable, which means there is no place to substitute that -3. G of -3 is simply -5. And when I go to evaluate g of -2, I'm going to run into the same issue. There is no x variable in that function to substitute in. G of -2 is simply -5. And that's going to happen for each input. The output is exactly the same. Let's go ahead and graph those points now. -3, 1, 2, 3, 4, 5. -2, -5. -1, -5. 0, 1, 2, 3. If I draw to connect those, I see what I have, a straight line. This is a special function. It's called the constant function, and you're going to learn more about that when we talk about parent functions. I love this function because it is what it says it is. All my inputs, right? I picked whatever I wanted, but my outputs were constantly the number -5. So the outputs remain constant. It's called the constant function. It will always be a horizontal line. Let's try another one. Given the function, oh, I cut off my graph. Okay, I'll have to figure that one out. Use the t-chart to determine the points, plot the function, and draw the graph. Okay, so we're going to have to kind of play around with this because I don't know where my other half of my graph went. So again, looking at our function right here, we can choose whatever we want to for our inputs. So -3, -2, -1, 0, 1, 2, 3. And then we're going to plug them in. So I'm going to have to add to my graph. Let's see, we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we're just missing the bottom half of the grid. So we're going to have to guesstimate that when we go to graph. It's fine on yours because I made sure it was fine on yours. All right, so if I plug in F, oh, it's G again. G of -3. That means I'm going to come over here to the function, -2/3 times -3 plus 3. Again, having a calculator will be very helpful to you. So that's going to give me 6/3 is 2 plus 3 is 5. And then the next thing I'm going to do is I'm going to do G of -2. And so that's going to be -2/3 times -2 plus 3, and so on. So that's going to be 4/3 plus 3, 4/3 plus 3 is 13/3. And again, having a calculator is helpful. Plugging in -1, I'm going to get 2/3 plus 3. And that's 11/3. Plugging in 0, I'm going to get 3. All right, so let's start plotting some of these points. Okay, -3, so this is 0, 0. Okay, 1, -2, -3, 1, 2, 3, 4, 5. -2, 13/3. So that's 3 and 2/3. Now, some of you may be realizing, hey, that's a line. -2/3 is the slope of that line. So I should be able to go down 2 over 3. Oh, look, there's my y-intercept, down 2 over 3. If you remember that, that's great. That is a more efficient way to graph a line. If not, I would continue to evaluate the function and plot all the points. Okay, let's do one more function, and that should be enough to get you ready to do our parent functions during the next class. So we've got k of x, again, the function named with a different variable, that's okay. Let's do -2, -1, 0, 1, 2. That should be enough for us to determine what the graph looks like. If it isn't, if you make a t-chart and you do all those points and you can't figure out what the curve or the line looks like, then just pick some more inputs. So I'm going to do k of -2. So that's going to be 1/2 times -2 squared minus 4. Again, notice my use of parentheses, really important. So -2 squared is 4, half of 4 is 2, 2 minus 4, -6. Then you're going to do k of -1. So that's going to be 1/2 times -1 squared minus 4. So that's going to be 1/2 minus 4. So 1/2 minus 4 is a -3.5, which is -7 over 2. Okay, k of 0. You're going to plug in 0. You're going to get -4. K of 1, you're going to get the same thing you got for k of -1, -7 over 2. And k of 2, you're going to get the same thing you got for -2. All right, so let's plot this. -2, 1, 2, 3, 4, 5, 6. Zero, 1, 2, 3, 4. 2, 1, 2, 3, 4, 5, 6. Why is this opening down? Okay, I found my mistake, people, because I can't subtract. This, first of all, it didn't make any sense to me what was happening with the graph, because I knew what it should look like, so mistake. -2 squared is 4. Half of 4 is 2. 2 minus 4 is -2. And so that should be -2. All right, so sorry. I knew it was supposed to be going this way. And if you don't want to plot those fractions, you could just go to like -4 and 4. Like maybe you just want pretty points, right? So -4 squared is 16. So you would do k of -4. So that would be 1/2 times -4 squared minus 4. So that's 8 minus 4 is 4. So -4 would give you 4 and 4 would give you 4. So 1, 2, 3, 4, 1, 2, 3, 4. And then -1, 2, 3, 4, 1, 2, 3, 4. And hopefully by now you're seeing some sort of a curve. Maybe you recognize it, maybe you don't. It's called a parabola. And that's the graph. So the key to graphing with a key chart is to make sure that you create a large enough list of domain or inputs that will allow you to get an idea of what the graph looks like. Then eventually you're going to learn what type of a parent function it is, which will allow you to graph it without the use of a T-chart. And that's what comes next.